Hi, I'm Dr. Incognito. In this video, we're going to discuss parametric equations and finding the formula for the slope of a curve given in parametric form and the second derivative, which will tell us about the concavity of the curve. So let's start with an example. Let's make up a curve in parametric form. Suppose that x is equal to t squared plus 1 and y is equal to t cubed plus 2t. So there's a curve in parametric form. T is the parameter. X and y each depend on t. So if we would like to know the slope of the curve at a point, that would be given by dy dx. And the formula for that is dy dt over dx dt. A nice formula using the Leibniz notation. A nice formula because if you treat this right side as a fraction, then it would cancel to dy over dx. Of course, we're not going to treat it that way. Dy dt means the derivative of y with respect to t, which is 3t squared plus 2. And dx dt is the derivative of x with respect to t. That would be 2t. So there's a formula for the slope of the curve. So one question we might ask, looking at this formula, is where does the curve have horizontal tangent lines and where might it have also vertical tangent lines? So let's investigate that. Horizontal tangent lines, that would mean that the numerator would be equal to 0. So first of all, a horizontal tangent line has a slope of 0. So that means that our derivative should equal 0. A fraction is equal to 0 precisely where the numerator is equal to 0, provided that at that same t value, the denominator is not 0. So let's look at this equation. Setting the numerator equal to 0, 3t squared plus t equals 0. This equation has no solutions. 3t squared plus 2 is always at least 2. So our curve has no horizontal tangent lines. What about vertical tangent lines? A vertical tangent line will occur when our slope formula has a 0 in the denominator, provided that the numerator is not 0. The derivative will be undefined. So the simple equation there is 2t equals 0. So when t is equal to 0, you will have a vertical tangent line. And that corresponds to the point. When t is 0, x is 1, y is 0. So the point on the curve will be the point 1, 0. Okay, next let's look at the second derivative. The formula there is d squared y over dx squared, that's the Leibniz notation for the second derivative, is equal to d by dt of dy dx, there's the derivative of the derivative, divided by dx dt. That's what the formula works out to be. So let's compute this. In the numerator, we need d by dt of dy dx. Notice that dy dx, which was just computed here, is a function of t. So this is equal to d by dt of 3t squared plus 2 over 2t. So we can use the quotient rule here to figure out the derivative of this. It would be the bottom times the derivative of the top minus the top times the derivative of the bottom divided by the bottom squared. And we'll simplify that. This is 12t squared minus 6t squared plus 4 over 4t squared. So the numerator is 6t squared minus 4, and the denominator is 4t squared. And now we can factor out a 2 in the numerator and cancel that. So this is 3t squared minus 2 divided by 2t squared. So that's the numerator of our second derivative. So our second derivative is the fraction 3t squared minus 2 divided by 2t squared. denominator of our fraction is dx dt, which we computed a moment ago when we computed dy dx. So dx dt was 2t. Computed again, 2t. So there's our second derivative. Of course, this form is bulkier than necessary. We can divide this fraction by 1 over 2t, by 2t by multiplying it by 1 over 2t. So this is equal to 3t squared minus 2 over 4t cubed. So there's a look at our second derivative. The usefulness of this is when the second derivative is positive, then the curve is concave up. And when the second derivative is negative, the curve is concave down. So if t, for example, here, if t is, let's take 3t squared minus 2 and set that equal to 0, t squared is equal to 2/3. So t could be plus or minus the square root of 2/3. So if t is bigger than the square root of 2/3, then this quantity on the top is positive and the quantity on the bottom is also positive. So if t is bigger than the square root of 2/3, that means that the curve is concave up. Just as an example of the application of this formula. Okay, thank you for watching this video. I hope you found it instructive.